This is mostly stuff we forgot on the ACT. From geometry. So everybody every year says there's a lot of geometry and triangles on the ACT and SAT. I do some algebraic stuff, but for the most part, I want to keep the stuff that you can answer rapidly without a calculator. So the things that we forgot in geometry were the opposite angles were congruent, or vertical angles, so that's 50. And then the angle sum of a line, like the angle sum of a line is 180. So if this angle is 50, you have to ask yourself what's 180 minus 50, and that would be 130. So all the acute angles are 50, and all the obtuse angles are 130. So W is a wide angle, so that's going to be 130. And Z is an acute angle, so that's going to be 50. All of these are pulled out of ACT prep books, and they discuss in extreme detail with a paragraph. This was a word problem, that the sides opposite were parallel. So it was like a parallelogram. Same idea with this one, that's 20 degrees. 180 minus 20 is going to be 160. And then every wide angle is going to be 160, and every narrow angle is going to be 20. So it's 160 and 20. Now this one, the arithmetic might be a little cumbersome, so maybe if it's not calculator active, you might have to do that by hand. I think it's going to be 145. So that wide angle is 145 degrees, and the narrow angle is 35 degrees. Again, this is nested in a big word problem. It states that all three of these are parallel. If you're in a classroom situation, they might tell you to set up a proportion, like line equals sine line, and it would be 3 over 6 equals x over 10. What I like to do is I like to set up the proportion right on the drawing, line equals sine line. And the move from middle school would have been 10 times 3 divided by 6. So 10 times 3 is 30, 30 divided by 6 is 5. Same idea with this one. I'm going to line equals sine line, set up the proportion right on the drawing. And then 18 times 5 divided by 15, that might be a little cumbersome without a calculator. If you had a calculator, it would just generate it in, or you can simplify this to 1/3, and it would be 18 times 1 divided by 3, and that would be 6. Another one, line equals sine line, 24 times 2.5 divided by 10. This one probably would be calculator active, but 2.5 is 1/4 of 10, so you could look at it like that. You could look at it as 24 times 1 divided by 4. So that would be 6. But if it were calculator active, I think it would be quicker to just do 24 times 2.5 divided by 10. It would generate the answer in the calculator. Coordinate plane stuff. The problem with this is it doesn't look like it's on graph paper. This here spot is the origin, that's 0, 0. And you have an x-axis and a y-axis. 0, 0, 0, 0, x-axis and y-axis. So it takes you a little while to actually put your brain around that. They're asking for point Q. So that point there is on the y-axis. So there can't be any x value. It would have to be 0 something. And in this case, you go right 0 up 2. So that would be choice A. Point S is the point they're talking about. That's on the x-axis. That means it's going to have a y value of 0. And I have two answers here with a y value of 0. But negative 2 would mean you go backwards. So the 3, 0 is the one where you have to go forwards. So the best possible choice for that one would be B. Point P, again, it's on the x-axis, but it goes backwards. That would be C, negative 2, negative 2. I'm sorry, negative 2, 0. R would be the one, if they ask for R, that would be the one that's out and up, right and up, 4, 4. It says the perimeter of a square is 40. A lot of SAT, ACT questions want you to do 2 things. They don't always want you to just do one idea. They want you most of the time to do 2 ideas, sometimes 3 or 4 ideas in one problem. So it might only be like 60 questions, but that's not true. It's actually about 90 to 100 questions because you have to answer 2 things nested in one problem. So how many sides does a square have? 4. So I have to divide that by 4. Once you do that, that will give me the radius of the circle. The radius of the circle in this instance is 10. Now it wants the area of the said circle that the square lies on top of. Area equals pi r squared. Now, for the SAT, they do give you a formula sheet. For the ACT, they do not. I wouldn't even bother using the pi key, because most of the time they're going to ask you. And this is the SAT reference sheet. It gives you some formulas for most shapes. All you're going to do is type in the 10 and square it. 10 squared is 100. So they usually want your answer in terms of pi. So it would be 100 pi. You would not put 314. You would multiply it by 3.14. SAT has some fill-in response, open-ended questions, but it's usually multiple choice. So I'm trying to find the radius. That's a key thing on these tests. They want you to discover what the radius is. So I'm going to divide that square. The perimeter of that square is 24. I'm going to divide that by 4. That's going to give me a radius of 6. So it's going to be 6 squared pi, or just 36 pi. Perimeter of the square is 12 divided by 4. That's 3. The area of the circle is going to be 9 pi. Formula for volume of a cylinder is pi r squared h, but this is asking for total surface area. They don't give you that formula. I don't believe you have to memorize it. That formula is not on the reference sheet. However, they will put the formula for it nested in the problem. 2 pi r squared plus 2 pi r h. Now, if it's in the non-calculator active section of the SAT, my advice is muchos hotchos. It's not a lot of h's. But there are a lot of 2's. There are a lot of pi's. And there are a lot of the letter r's. I would factor out the GCF, which is going to be 2 pi r. And then when I divide each of these terms by 2 pi r, language, that would give me parentheses r plus h. Now this can go rapidly if you have this idea. Without a calculator, what's 3 plus 8? Without a calculator, radius is 3, so what's 2 times 3? So that would be 6 times pi times 11. So the total surface area would be 66 pi. Let's write it down again. 2 pi r plus h. I can do 4 plus 10 rapidly in my head. That's 14. 2 times 4, the radius is 4 is 8. So it's going to be pi times 8 times 14. If it's not calculator active, the arithmetic isn't that difficult. That's 32. That's 8. It's 112 pi. Once again, total surface area. 2 pi r plus h. My r plus h in this situation, 8 plus 12 is 20. And then 2 times the radius is 16. 16 times 20 times pi. I believe that's going to give me 320 pi. SOHCAHTOA. Going to show up a lot. SOHCAHTOA. So it's asking for the tangent of angle theta. And angle theta is just a Greek letter for, hey, that's a variable for that angle. So opposite that angle, this side here is opposite. This side here is adjacent to that angle. I know the hypotenuse is adjacent to the angle, but it's the hypotenuse. So let's label it as such. So tangent is opposite over adjacent. So that's going to be A over B. A over B. Cosine. Cosecant. I'm sorry. I made that mistake. Now, I don't have a SOHCAHTOA for cosecant, but we have to realize that cosecant is related to sine. So cosecant is related to sine. It's actually the flip of sine. It's hypotenuse over opposite. So I'm going to find the sine of theta. Sine of theta is A over C. So that's A over C. The cosecant of theta would be C over A. Cotangent, all that is the reciprocal of tangent. So I already have the tangent there. It's just going to be B over A. These aren't considered high-level questions, but if you don't brush up on this, it'll slow you down. You're supposed to do these rapidly. I have a rectangle. Now, this side of the rectangle is 3. That means this side of the rectangle is 3. I'm going to need this side or the bottom. I'm going to need this side, which is the same as the bottom. So I'm going to need that side. Again, here's a scenario where you have to do two things in one problem. And the first thing you have to do is the Pythagorean theorem. So I'm going to do 5 squared minus 3 squared. 25 minus 9, square root 16. So this side here is 4. That means this side is 4. Now I can do tangent of A. Tangent of A is opposite of A, which is 4, over the adjacent of A, which is 3. Once again, this side is 5. That means this side is going to be 5. If this top side is 12, this bottom side is going to be 12. Sine is opposite over hypotenuse, so I have to do two things. I cannot just do the sine ratio. I have to find the hypotenuse. That means I have to do Pythagorean theorem. So for this case, Pythagorean theorem, it's going to be 5 squared plus 12 squared. That's going to be 144 plus 25 is the square root of 169. So my hypotenuse is going to be 13. Now sine of B is opposite. That's 5 over the hypotenuse, 13. Cosine, again, I need the hypotenuse. They don't give it to me. So I'm going to do Pythagorean theorem. Square root. This side is 7. This side is 7. 24 squared minus 7 squared. I don't add them. You add them when you're looking for the hypotenuse. Oh, you do add them. You add them when you're looking for the hypotenuse. You add them when you're looking for the hypotenuse. You subtract them when you're looking for a leg. You subtract them when you're looking for a leg. 24 squared plus 7 squared is 625. The square root of 625 is 25. Cosine A is adjacent. That would be 7 over hypotenuse, which is 25. No, you would think secant would be related to sine, but it's not. It's related to cosine. Who came up with that? I don't know. And cosecant is related to sine, but cotangent is related to tangent. That's easy enough. So the secant function is going to be dealing with the cosine. So I'm going to find the cosine of this. The cosine of theta is adjacent A over hypotenuse C. So the secant is just going to be the reciprocal of that. C over A. Cotangent. Well, tangent is opposite. That would be B over A. So the cotangent is just going to be A over B. Now, everybody at the high school level, junior year, should know that sine squared plus cosine squared equals 1. But you probably don't. Alright? So sine is opposite over hypotenuse. So that's going to be B over C. If I do the arithmetic, B over C squared plus cosine is A over C squared. Let's see what happens. That's B squared over C squared. Plus A squared over C squared. I now have a common denominator, so I can rewrite this as B squared plus A squared over C squared. Can anybody tell me what the Pythagorean theorem is? I think it's A squared plus B squared.